Coming up on the next episode. Good Thursday morning to you all, YouTube. It is 10:56. I'm here today to explain how to go from start to finish on a 3D print. Obviously, the first thing that you're going to have is a printer. But, you know, there are ways of doing this without a printer. And like I said, this is the steps that you have to do. Basically, the first thing you need to do as far as the first step would be to design something that you want to print. Now, you don't have to do this. You can do this. If you Google just anything that you want to print, radio case, just put that on Google and put 3D print next to it as far as say radio case 3D print. And it will pop up a bunch of designs from places like the STL Finder, Thingiverse, Yagi. There's all kinds of places out there that search for that kind of design. And you can find those designs on there. And like I'll say, let's just do one real quick. Let's see. That's Tinkercad. We're not getting there yet. Let's just say radio case 3D print. Now if you look at that, radio case 3D models to print Yagi comes up first. There's some more there from Yagi. STL Finder comes there. Thingiverse is down here. And you can click on any one of them, and I'll click on the Yagi because it came up first. And get some ideas or even get a design. It's pretty simple that you can see the things that people have printed before you. And I'm gonna click on one of the simple ones just to show you what pops up here. And you see this takes us back to Thingiverse, and that shows you a picture of it. And there's the top and bottom of it. It's just like a transistor radio case. It looks like to me like. In fact, that's exactly what it is, I believe. Crown TR680 radio case, and that's how simple it is. Right here you can see, you can click on this thing. It says download all files, and you can actually download that and print that out without doing anything else. In other words, you don't even have to design anything. You can just basically do that. Now I wanted to kind of show you that, to go over the steps that you have to do. If you go down here and look at the notes, sometimes, well, this one doesn't have any notes. But sometimes in the notes they'll tell you exactly what you need to do as far as slicing it and things like that. Now that's another term that will pop up in 3D printing from time to time. So let's go over again the steps. Let's get out of this, out of that. Now, if you, let's just say you want to design your own whatever it is, and I don't know what it is, but we're going to just play around with it a little bit. See, I told you guys yesterday or whenever it was I made that video how simple it was to make some of this stuff. Now there's a cylinder. You can see it is 20 millimeters high. It is 20 millimeters by 20 millimeters on the diameter. And so it's a perfectly round circle, okay? So now, what happens when we want to, say, make a something go through that? In other words, we want to make the center of that hollow. And we take this cylinder here. Now, I don't know how you can see that, but this is a block cylinder. You know, it actually is this piece here. This is a what they call a transparent block. It's the same exact size. You can see 20 millimeters on the diameter. So if we put that on top of that and join them, or group them as it's called, it would just take that away, and that wouldn't be what we want. So let's reduce this to 18 and 18. Now that's smaller, obviously. Okay, So basically now if we take and put that on top of there, which you can do, like that, and we can look at it this way and you can see it a little bit better. Now, one of the things I struggle with at the beginning, let me zoom in a little bit on this. One of the things I struggled with at the beginning of this is getting things aligned. You can see there that's not aligned very well, but there is a way of doing that. You select both of them and go up here to the alignment tool. Click on that, and you want to center it both ways, so you click on the center there and click on the center there, and there it is, perfectly centered. Now that's in itself kind of neat, right? Right. Now, okay, but now you've got a transparent block in the middle of a solid block, or a cylinder, I'm sorry, and you want to you want to turn that into a hollow cylinder. So how do you do that? Well, okay, you just again select them, go up here to this tool which says group, join. I always say join because that's exactly what it does, and hit the button, and there it is, hollow. That is how simple that is. I mean, guys, you can't get no more simple than that. I mean, it's unreal how simple it is. So you want to put a block on it? We can put a block on it. Now, if you do something like that, then what you're going to have is basically have a moon there. You'd have to go back in and redo that again. So always you want to do your whatever first, and then do it like I said. It takes some time, is what I'm trying to say, to learn how to use this as far as the best way, the most efficient way, I guess is how I should say it. And yeah, you can align these as well. Go here and just align it this way. It's already in alignment that way, so that's all I was trying to do. So basically that's all there is to that. And again, that would be it's not useful, but it'd be something to print. And so I just kind of wanted to go. I'm not gonna go through this and totally do it, but like I said, I just kind of wanted to go through this and show you what it is that you can do with this, and that in itself is kind of a nice thing. Now I can make this, or you can do it a little bit different. Let's put another block up here. Now that we know that this is 20 by 20, in other words, 20 diameter, and we know this block is 20. If we look at it, see that's 20. So this is 20. Now if I just put that in there like that, it's going to cut out. Well, I can show you what it'll cut out. It'll cut out most of that. So you don't want to. You want to put it there, and that way when you join it together, it will be still have this hollow part over here, and it won't be hollow over here. So that's what you want to do. So that's pretty much how we want it right there. So let's join these two here. Now it depends on what you select is what you join. So you can see I just joined that right there, and I'm gonna move this over here, and we're gonna join that with that. Again, we need to make sure it's aligned, and it is. So all you have to do now is do this and join them together, group them, and now you got one piece. That's how simple that is. So you guys see how Tinkercad works. It just works with shapes, is all it is. And like I said, if we want to print this out, which we can do, I'm going to show you how to do that real quick. You select it. We go over here to export, and it says the selected shape. That's what we want to export. For 3D print, we want to choose STL, and it takes and puts it in my 3D designs. It says blank design. That's fine, because that's all we're going to mess with. And we're going to save that there. And now it's saved. We'll get out of that. Go to 3D designs here. And I should have one called blank design there. Where did it go? Do. I never can find these things. Oh, right there it is. Blank design right there. Okay, so now what's the next step? We have our shape that we want to print, and we have to get it in some form that the printer can understand, and that is called G code. That is what the printer worked with. That's I think it was developed for CNC type machines. Tells basically the stepper motors which way to go and how far to go and things like that. And it's a pretty simple. If you looked at the G code itself, it's pretty simple looking. It's just instructions about how many millimeters to move and things like that. And so that's all you have to do. But how you do that is with another free program, and that's called Cura. And I'll open that up real quick. And this is called slicing. You guys have heard that term, I'm sure. Anybody that's heard anything about 3D printers. Again, these programs are all free. Tinkercad's a web design or web program. It's right on the internet. You just click on it and go to town. You see there's a thing called slice here. Now I can move this around just like I did in the other one. You can see there's our basic shape. Not much to it, and I'm not going to print this, but we're gonna get it out here. We're gonna slice it so you can see what that does. That's going to make our G code when we slice it. Now I'm not going to go over too much about the printer settings, but mine is a Creality Ender 3 Pro. You simply select that in Cura, and that tells Cura what your printer settings should be and things like that. Most of the common printers, popular common printers, are in this. You can just select it right there, and like I say, it's pretty easy to do. So, and it gives you the general stuff that you need to do your nozzle. You don't really have to mess with that much. You just make sure that you're set to whatever you're printing with. This, you see a generic PLA, and that's what I've got in there. Your quality, you can choose your quality. Basically, quality, it goes from let's see. Let's see if I can find it. I thought there was one in here that would let you choose. I know there is. Oh, standard quality right there. That's the profile that we're using right now. You can choose low quality, and that's your draft type quality. If you want to print something up, just see what it's going to look like and not use a lot of filament and things like that, you can use that. I pretty much use standard quality for most of my prints. Now occasionally I've used dynamic quality, which is a little step above that. It's a little bit better. I've not tried super quality yet, so I really haven't experienced that. So again, standard quality is what I usually leave mine set on, so that's what we're going to mess with. We're not going to mess with it. This number here, this 20%, is the infill. Infill is basically, when you print this up, it's not a solid piece. It's got, it will print the outside of it solid like that, and then it uses infill to fill in around this to where you can, let's get this a little closer. It uses infill to go in there and fill in. You've seen, if you broke apart any plastic parts, you've seen, inside of it, it's just kind of hollow with lines going back and forth, things like that. That's what that infill is. But you don't really have to worry about it. But 20% is a good figure. That seems to work rather well. There are times you probably want to increase that. Now these other two things here are to do with the bed adhesion and whether you want support. Now for this one you wouldn't really need any support because it's a straight print. There's no overhangs. Anytime you have an overhang, if you had something come up here like this and go out like this, well, you need support for that because obviously the printer can't print straight out like that up in the air. It just can't do that. So you need to have support. But that's all there is to that. So we're not going to do that because we don't need it. So we're going to just slice this real quick. And when we slice it, you see it takes 30 minutes to print. And that's how long that block right there, or that little design that we made, would take to print. And again, what that does is it says save the file. We can do that. Brings up a thing here, and it tells you mine saves as CE3 Pro, and it says blank design, which is the name, and G code is the name of the actual file. So if I save that in there, like I do that, that way I have that file saved. Now, the way that you print it is either you take it and put it on a little SD card and walk over to the printer and insert that into the printer, and then choose that file from the control panel of the printer, and it will print it. That's how simple that is. Or in my case, I use a program called Octoprint. Octoprint, I think, is a much cooler thing to have, because now it takes a Raspberry Pi to do it, but still it allows you to basically do everything right from here. If I wanted to upload, see this last thing I did, we can get rid of that. If I wanted to upload that blank design, I'd hit upload blank design right there and hit open. And there I am, loaded into the printer cache, or whatever you want to call it, queue. And basically, like I said, it would start printing that, if I hit the right button, this is load and print right there. If I hit that, it would start printing that out. I'm not going to do it because I don't really need that, but like I said, that's how easy it is doing in Octoprint. And then Octoprint also provides, if you got the camera with it, you got a view of it, so you can watch it print. Like I said, I can go back in my bedroom in the shop and see on that computer, see the same picture I see in here, and watch that print. So if I want to know if it's about done or whatever, I can just look at that image, and it shows you what's going on. Kind of neat. But again, back to the other one. If you just put it on an SD card, you can take it over to the printer, stick it. There's an SD card slot on the printer. Stick that in there, and then go over to the control panel and select that print that you got on that card, and start printing. And that's how simple it is. You don't really have to know anything. You don't really have to do anything. And I know it's oversimplified. I agree. Yes, it is oversimplified. But that's the steps that you take to make a 3D print. Pure and simple. You can either choose a design from on Google and look for a design that you want to print. Go that route. And what that does is gives you an STL file, and you still have to slice it, because it has to be sliced for your particular printer, for your settings and things like that. That's why they don't have the G code on there. You have just the STL file, which is the design itself, and then you slice it with the Cura and basically print it on your printer, and that's how that works. So I hope that's been helpful, Leo. Again, that was oversimplified. I agree, but that's the steps involved, and that's how the printer works. It works with the G code. If you know anything about, like I said, the CNC type stuff, that's what G code comes from. And a 3D printer does exactly the same thing. It just takes those instructions and moves the print head from one point to the other, and extruder. It also tells the extruder to push more filament through and things like that. And again, that's pretty much how simple. Now there's more to it as far as how you set your temperature, your bed temperature. But those things you learn. You can start out with the default, which is what I did, and I learned pretty quick that when I put that spool of ABS on there, thinking it was PLA, that there's a difference in different plastics, that you have to set your bed up and your nozzle temperature differently for ABS than you do PLA. But that stuff, like I said, you learn as you go, and if you run a few feet of filament, believe me, it's not the end of the world. Filament's not that expensive, but the huge roll that I just finished was like $20-something, 21, maybe 20. I don't remember exactly what it was. But it printed a lot of stuff, and like I said, again, a lot of enjoyment for me. So Uh, that's the main thing, I think, is have fun. So again, Leo, if there's anything I can specifically answer for you or anything like that, let me know. But that's just a general look at how easy it is to do print something, even if you design your own. It's not that hard in Tinkercad. I mean, Tinkercad is a lot of fun to play with, really. It's like building blocks. It's like when you were a kid, you played with building blocks. That's pretty much what Tinkercad is. It just takes you build things from blocks and cylinders, and so it's really that simple. And again, I say the programming that you need for this is all there. It's free. Now I'm using Linux, and I can find it all in Linux. I'm sure you'll find it in Windows if you're using Windows just fine. In fact, I know you can. I've used it in Windows. But so that's going to be it. Like I said, if that helps, I'm happy. If not, I'll answer any questions you may have. But that was pretty much it from start to finish. How you do it. The Again, if you don't get a time estimate, or you get the time estimate when you slice it in Cure, and that's a pretty accurate time estimate I've found. Most of the times, that's exactly how long it takes. The last thing I did was the light bracket, the improved light bracket that will hold my light up a little higher, and it said 3 hours and a half, something like that, and it was right on the money. So, like I say, that's how it works. So you guys, hope this helps anybody that's thinking about this. Again, I'll be happy. I'm not the best teacher. I've told you guys that many times, and I have it all in my head, things I want to say, but sometimes they don't come out my mouth the same way that they're in my head. So, like I say, if you have any questions, let me know, and I'll try to answer those. So you guys have a great day. Thanks for watching. We'll see ya.